Good morning, everyone. How are you today? Cool. How many people from abroad? Oh, that's a lot. You're not from abroad, are you? Okay. Great. So I'm really glad that I can see all of you here. It's my great pleasure that we have so many great speakers from foreign countries here, like Ivan, who's going to talk about.
It's a surprise.
It's a surprise. It's gonna be great. I believe that the whole event is gonna be great. So thank you that all of you came. I also would like to thank to the sponsors, because that's only because of them that we could make this action for you. So please, when this is going to finish, just go and visit the sponsors, talk to them, and thank them for for this conference to be part of this weekend. So I believe that's it. Thank you. Thank you for coming. I hope you will stay as long as possible. At the end, there will be some raffle show, so you can win really good prizes, but you have to stay till the end. I totally recommend to do that, because the prizes are really worth it. So that's it. Anyone? It's yours. Thank you.
Okay, thanks. And besides the sponsors, I have to add something else. This event will not happen without the organizers, without people like Pavel, Jaro, Tomáš, and everyone else that I cannot remember all those names, honestly. So it's Saturday morning. It's an unusual thing to do SQL on Saturday morning, unless you have some kind of an issue, I guess. And today I want to start with a little story. I applied for SQL Saturday here the moment I understood that there's going to be one. And a month ago, Jaro actually confirmed that, okay, this guy will participate. And I was like, yes. That's a great event. So I want to be there. And that's the first one here. So it has to be the greatest. Of course, when I need to plan a travel, I need to know a lot of stuff. So I got accepted to speak at this event. And okay, this column is kind of strange. So I apologize for everyone that will not be able to see me. I'm kind of a white person, so probably you can see me from all angles, but anyway. So I have to come to Prague. I have to prepare a plan. And I cannot just, I don't know, take my bag and just go somewhere. I'm a guy who prepares those plans. So it's really important for me, first, to understand what are my possibilities to get to Prague. So either it's going to be airplane, car, I can walk. Of course, it would mean that I would need to walk a month. So right after the approval email, I would have to start walking. Or I could use a teleport. Can I? I only wish. So I have to make a decision. And this decision is based on certain circumstances or certain things that I need to take care about. Like the time, the condition that I'll get to that place, because believe me, if I walk for a month, you wouldn't want to see me presenting here. Not saying that I will be able at all, but anyway. So, natural choice, okay, let's go with an airplane. The next thing I need to know, okay, how do I get from the airport to my hotel? So again, I can teleport myself. Again, I wish. I hope we can do that in a few years. I can use taxi, I can rent a car, I can use the metro or the bus, and as usual, I take the public transport in Prague, because it's one of the best that I have used, honestly. I can get to anywhere, and it's pretty easy for me to know on which stop I need to get off to. The next thing I need to decide is, all right, which is the hotel that I'm going to stay? And again, I have some prerequisites for that. Like, it has to be close to a metro station. It has to have stable Wi-Fi, because I'm checking my Facebook like regularly. It has to be close to points of interest, and it has to be next to a place where they have draft dark kozel. Honestly, that's really important for me. So I choose an hotel at Wenceslas Square. All set. I know how to get to Prague. I know when. I know where I'm going to stay. I know how I'm going to do it. So I call this a plan. Welcome to the plan cache session for this Saturday morning. Why I started with this story? Well, obviously it's for a reason. I mean, I'm not just talking like to get you awakened. SQL Server is pretty much using the same or close to this algorithm to decide how exactly it's going to get from point A to point B, or the data that you want, the way you want it. So it's extremely important to understand how SQL Server is doing the plan cache and where exactly the SQL Server plan cache stands in the execution model and data retrieval within your queries. Am I going too much? Do you feel like on a tennis game? My name is Ivan, or I don't know, it really depends who you ask. I work for Microsoft. I'm doing SQL for more than 10 years. Probably some of you already know me from the SQL indexing session that we did. What was that? 2 months ago or something like that? And I cover a lot of countries. So you can guess that I travel. That's why I have all those plans. Let's call them execution plans or travel plans, whatever. When they call me, I just take my suitcase and go. Basically proactive, reactive, anything that has to do with data. And I love it. It's a really great experience. I mean, there's no same customer, no same issue in 2 consecutive weeks. This is great. And I already have been working with 3 banks in Czech Republic. You can ask the guys around. I already bribed them so they can say a few good words for me, I guess. So let's get back to our plans. I get my plan for travel. Everything set. I have it in written, right? But I'm not going only to Prague. I'm going to so many different countries. Can I reuse the same plan for different countries? Sometimes I can, sometimes I cannot. For instance, even if I want to have draft dark Kozo in, I don't know, in Germany, probably it's not that. Let's say, the word escaped me. I wouldn't expect it to be happening. So, I create my plans, and usually my desk would eventually look like that. I have a plan for Prague, I have a plan for my customer in Bulgaria, I have a plan for my customers in Belgrade, and everywhere else. Usually, I think it's that ordered. And usually I think I can at any time reuse any of those plans. But sometimes I'm out of space. Sometimes my cat goes on the desk and just shuffles everything, and I get my plans lost, and I need to create new ones. It's really similar to what SQL Server is doing. The SQL Server plan cache has really a central place in the execution model. It's extremely important. Like, it's the first thing that needs to happen, pretty much the first major thing that needs to happen before you get your data. This is the execution model, and I took that picture from Remus Rusanu's blog, rusanu.com. He's one of the principal SQL developers that worked on the product for, I don't know, a lot of years. He's not in Microsoft now, he's running his private company, but I strongly recommend his blog, rusanu.com. So you get internals there, a lot of internals, including the execution model. So take a look. The plan cache. Okay, obviously the laser is not pointing up. The plan cache here, do you see it? Okay. The plan cache plays a huge role. The moment you start executing your query, you need to have a plan for getting that data. You cannot execute anything in SQL Server without knowing how this data will be retrieved or how this thing will be executed. Now, I'll focus on really quickly on the execution model of SQL Server and where exactly the plan cache gets in action. So imagine that you push a query, no matter what query. You push a query to SQL Server. The first thing that we do is, all right, we have to parse it, normalize it, see if you have syntax errors. We have to bind it to existing objects and so on and so on and so on, compile the SQL, and load all relevant statistics from the engine. I won't talk about statistics, I won't talk about query optimization. I just really want to quickly point to where the execution plan is written to. So once we load all those statistics, we do the optimization, and after we do the optimization, we found our best plan. Like in my case, I can choose another hotel, or I can choose walking, but it's not the best cost for me to get to execute this plan. So I optimize my plan, hence using an airplane. That's what SQL Server is doing. So the moment it optimizes it, it stores it in the plan cache before even getting to execute it. Now, this is the first time we store the execution plan in the plan cache. Next, if we submit a second time a query, the same query or the same store procedure, SQL Server will first check the execution plan to see if there's something already prepared for him, so he doesn't really need to do the whole compilation and optimization thing, because it takes time and resources. So let's reuse the plan. If the plan is already in cache, then we load it, but we need to test it for correctness. Because you might have created the plan with that was using 3 different indexes, and you all of a sudden decided that, okay, I don't like those indexes, I'll just drop them. Is that execution plan, will that execution plan be able to be reused? No. So SQL Server will have to generate a new plan. So it has to do recompilation. The next thing, once we do the recompilation, let's say the plan is correct. Now we need to test our recompilation thresholds. Recompilation threshold is pretty much the amount of data that changed since the last time we compiled our execution plan. And for that, I actually have a question around this. When you see this icon, it means that I have a question. And for correct answer, I'll be giving out tools. Tools for better, let's say, administration, for instance. Database administration. Now, my question here is, in SQL Server 2016, what is the recompilation threshold? Or how much rows we have to change before we trigger an auto-update statistics?
20%, and it depends on the size of the table.
2016, 20%? This is for 2014 and below.
But when there is like more rows than, I don't know, 1 million, I'm not sure, then the threshold drops.
Yeah, but so do you know the formula behind it? I'm looking for the formula so we can get the tool. Come on.
Before should be 20% plus, but that was before.
This is the tool. This was before, yeah. So, what's the formula? Come on. I want to give away this tool, please. Otherwise, they won't let me in the airport, you know. Come on. Square root of the table cardinality multiplied by 1000. You should know this. Okay, anyway, you were closest to the answer. There you go, a tool for better database administration. You can use it as a coffee, for instance. I mean, after all, it's Saturday. So, what is the SQL Server Plan Cache and where exactly it stands for? It stands in. So, it's part of the SQL Server buffer pool. The buffer pool, this area that you control with the SQL Server max server memory setting. You know that, right? Yeah, you know it, I hope. Then the Plan Cache is sitting together on one level with the data pages. Now, the data pages are a larger area, but just for illustration purposes and so I can fit everything on this slide, you can see the data pages are here smaller, but generally they're way larger. Now, the plan cache has 4 cache stores inside. The object plans, the SQL plans, boundaries, and extended store procedures. Now, those 4 areas serve very specific purpose. The object plans contain execution plan cached for stored procedures, triggers, basically stored procedures and triggers, yes. The SQL plans are for ad hoc statements. Do you know what an ad hoc statement is? The one that is not executed via a procedure, basically. Then we have boundaries and extended store procedures. Every cache store has a hash table in which it collects all the entries. And there is DMV for that, where you can check it. I'll show in the demo. And do you know how large that hash table is? It's for each of those, it's basically somewhere the maximum amount of cache plans that you have is something around 160,000. Now, how do we fill in those hash tables? In basically each bucket, each of those cache stores have a specific amount of buckets. So the hash table has a certain amount of buckets, and this certain amount of buckets is 40,000. So the object plans and SQL plans has hash tables with 40,000 buckets each, and then the boundaries have a lot less, something around 1,000, I think, and the extended store procedure has a fixed amount of buckets, 127. That's it. You don't get more for extended store procedures. Now, how do we fill in those buckets? Well, we are using this formula. Object ID multiplied by the database ID modulus the hash table size. And that's it. The moment you get 4 times the size of the hash table, you trigger an internal memory pressure. So the moment you get more than 160,000 plans in those hash tables, you get an internal memory pressure. This is extremely important. Now, how do we define the max size for this plan cache? Because it's not supposed to grow until it hits the max server memory. It has a limit. And that limit is defined as follows. 75% from the target area between 0 and 4 gigabytes, plus 10% of the target area between 4 and 64 gigabytes, and 5% from everything else. So if you have a SQL Server 2012, or 2014, or 2016, whatever, and you have 128 gigabytes of memory, this is the formula, and this is the maximum amount of memory in the plan cache, the target or the maximum that the plan cache can go. And this number is important when you define internal and external memory pressures, but we'll get there. 2 questions. Looking at this formula for this SQL Server, can you guess what the addition of the SQL Server is? What the addition of the SQL Server is? Sorry? Enterprise. Who said that? Why? Yes. There's a 2. Yes, it should be the dark one. I should have saved it for last. In SQL Server 2012, actually the SQL Server 2012 was the last edition where in standard you can have up to 64 gigabytes. After that you can have up to 128 gigabytes of memory in standard edition. So, we continue with the basics. We plan cache, we submit our query, it gets compiled. When it's compiled, we calculate so-called SQL handle. The SQL handle is a thumbprint of that very specific query, with all its commands, with all its spaces and everything. If you submit the same query, even with 1 line more, like you just hit enter, or 1 space more, this is going to be a different query. Nevertheless, you're pretty much doing the same thing in the select statement and join statements and everything else. So be careful, and this is valid only for the ad hocs. That's why stored procedures are extremely good in that sense. I mean, you compile it, and no matter how many spaces and comments you put, the moment you hit execute this stored procedure, that's it. once we have the SQL handle, we are producing a plan handle. Now, the plan handle is, as you can guess, a thumbprint for the plan cache that we have produced and stored in the cache. You can get the SQL handles and monitor those or dig into those in sysdm exec SQL text, providing SQL handle. This is practically a DMF function. And sysdm exec query plan, where you provide the plan handle. Now, we produce a plan, and this plan is produced based on certain values. But whenever you execute query, you usually supply different parameters for stored procedures, right? So you're not executing the same stored procedure with the same parameters every time, right? So there's one more level below the plan handles, and this is called execution context. The execution context is basically a copy of the plan that we cached, but storing also the parameters that it's executed for. So if you have one statement that you have a plan cache for, and 10 different executions with 10 different values, you get 10 different execution contexts. And you have a DMV to monitor this as well. And the relation is one to many. I will show you all those things in the demo. Oops, here. Now, I didn't mention that if you have any question, you can straightforward ask it. So, any questions? Is it boring so far? I hope not. So, I'm using AdventureWorks 2014. You can download that for free. After the demos, after the session, sometime next week, I'll share the demos and the slide deck and everything on the site. So, keep monitoring it. So, I'm doing DVC free proc cache, something that you do or you do not have to do in production. Come on. It's not a tool question, but anyway. Do you do that in production, honestly?
Do you want slowly your server?
That depends. Sometimes it's extremely necessary. But by the end of the session, I hope I'll provide you several other ways to still free procedure cache, but only on the things you really like makes your server slow or bothering your plan cache. But we'll get there. So I'm executing 3 stored procedures. So they return something, and this is dm exec cache plans. This DMV gives you basically the details on whatever you have in the plan cache. You have the bucket ID, ref counts, use counts. Now, what is ref count? Ref count is basically, can you guess?
How many references are spotted?
Sorry?
How many references are pointing to this bucket?
Yes, basically the execution context, or the copies of that plan that is stored in the plan cache dependent objects DMV. I'll show you just later on. The use counts, how many times this particular plan has been reused. It's extremely important to look on those use counts, because I bet that you have at least one SQL Server in production that has 90% of its plans that are used only once. And I'm ready to bet on that. Then the size in bytes, which is important. The memory address, what kind of an object is that? Like compiled plan, boundary, ad hoc statement, and so on and so on. And then the plan handle itself. So this is something that, this is the value that you supply to sysdm exec plan cache to get the cache plan. Now, let me get it one step further. I'll take the cache plans and I will supply the sysdm exec query plan handle, so we can actually see the execution plan. So if you wonder which is the query that has been reused the most, or has the largest execution plan, what's the largest execution plan size that you have seen? Or you haven't paid attention at all? My personal record, let's say, is 11 megabytes execution plan. So 11 megabytes of this info. Can you imagine how large that is? Now, there's a bug in Management Studio, this version of Management Studio, so they fixed it in 16.5, I think. Generally, when you open up, when you click here, you should open up the graphical execution plan with all the operators and everything. But I guess we're one step back with this version. Anyway, so the next thing. I want to see the queries that go behind that execution plan. Great, so sysdm exec query stats, sysdm exec SQL text, and then I am able to get my plan handle, SQL handle, my statement. Now, pay attention to this. Why am I seeing create procedures? Does it mean that when I run my queries, my 3 stored procedures, I'm actually creating them from scratch? What do you think? No, it doesn't. It's just how SQL Server is storing it in cache. If you notice here in the beginning, we have start and end statement offset. And SQL Server is producing a plan cache for each SQL statement as well. So you have both a plan cache for your entire batch, but you also have subplans for each statement. So, if I want to understand exactly which statement from which procedure this plan is for, I can do some calculations with substrings and text and actually get only the text between the start and end offset. So in the end, I get something like this. With some CT, something, something, something. This is the execution plan for this particular part in my plan cache. Okay. Something interesting. And this is the first really important lesson that you need to learn. Now, I'm freeing up the procedure cache. I am going to execute select star from person.address, where city is equal to Seattle. And I'm going to execute the same. So, I am executing the same statement, right? Would you expect that SQL Server is going to reuse the execution plan at this point? Come on, raise hands. Who is for reuse? Who is against reuse? Okay, so we have a couple of guys that cannot decide. Okay. Huh? Who said he's not going to reuse it? You win. Why?
Because that's a new string.
Sorry?
That's a new string. You execute the new branch.
It's the same string. I mean, but you're right. Basically, if I execute the same, if I didn't execute the same string, it's going to be a new. The problem here is there are certain set operations that if you use in your batches, in your stored procedures, they will force recompilation. Quoted identifier is one of them. In MSDN, there are a lot, and in the end of the presentation, I'll have references, so when you open them, you will see all those details. So if you use set quote identifier on in your procedures like 5 times in your single procedure, you get 5 different recompilations. Cool, huh? Are you using set commands on different places in your stored procedures? No? Yes? You don't know? Well, you have to check now. Now, let me show the execution context as well. So, the same query. I'll be careful with the spaces this time. Yeah?
Why are you getting an error when you try to free cache?
Sorry?
There was some error when you tried to free your cache.
Was there? I didn't see. No. Yeah, I mean, obviously I had to drink three coffees, not 2. So, okay, again. Check this out. This is the sysdm exec cache plan dependent object. It has a version for each different parameter. So if you want to know how many versions or how many different execution parameters you have for your stored procedures, this is the place you look into. Something else. Now, if you submit those 2 queries, would you expect two plans to be generated or just one? Let's see. I'm going to include my actual execution plan. Take a look at something. This is the query that gets cached in my execution plan. All of a sudden, my parameter, my literal value was exchanged with a parameter. This in SQL Server is called simple parameterization. And simple parameterization is acting by default. And simple parameterization is acting only in certain conditions. And SQL Server attempts to parameterize, to replace with parameters literal values only, and only if it is able to produce a safe execution plan. Have you heard about safe execution plans? No? Yes? Safe execution plans are basically trivial plans, or plans that whatever you submit to SQL Server, it will always use this plan. Such plan is, for instance, when you submit a query that will always return 1 row, and it will always use an index seek, for instance. So, SQL Server, because I have an index seek here, SQL Server estimates that it will always, absolutely always, give me just 1 row as a result, or it will always use the same execution plan, whatever parameter I provide. Hence, it will parameterize. Is that a good thing? What do you think? Sorry? Yes, of course, with Microsoft always depends. But anyway, why? Depends on what? In this case, it would be okay, because the next time I submit my customer ID equals 2, I will reuse that execution plan, and I'll show you. But when this approach would be an issue?
Well, in this case, customer ID is the primary key, so the problem won't be.
The same plan is not good for the plan.
Exactly. So basically, SQL Server will produce a plan for that first parameter that you give to SQL Server, right? But can you imagine that this parameter is not really good for, that this execution plan is not really good for every other parameter in that query? Let me execute it with number 2, with customer ID number 2, and let me show the results. See, a single execution plan gets cached. Its size, oops, sorry. Its size is 40K, and it's being used, oh, damn it, it's been used 2 times. And take a look. This is what SQL Server is caching. It has a definition of a parameter, and it's replacing the literal value with a parameter. It's storing it as a compiled plan that has been prepared. This is important. It's not an ad hoc query. It's a prepared query, which is different from ad hocs. Prepared queries are stored where? In the SQL plans or the object plans? Object plans, yes.
I have a question.
Yeah, go ahead.
Where is the execution plan for your last query? For your last query, like you are querying for the customer ID, and then you are selecting from the DMUs.
Yeah, the next time I execute the same query, then it will be there because it's giving me the results before my query gets cached.
Okay.
So the next time I execute it, it will be there. So, how do we execute queries in SQL Server and how it relates to SQL Server plan cache? First, you can use store procedures, obviously. Now, question for you. Are you using sp underscore, xp underscore, and fn underscore for your naming convention? Well, don't mind what I wrote there. Are your stored procedures in your database named sp underscore? Come on, admit it. Now, what's the problem with that? Whenever you use sp underscore, xp underscore, or fn underscore for functions, SQL Server always expects those to be system functions, so it goes to the master database to look for them, which generates a cache miss event. So SQL Server has to go again in your user database to look for that object. You can catch those with extended events or with Profiler if you're still running old SQL servers. There is an event, cache miss event. And this is directly affecting your cache plan cache hit ratio in perf mode. What? What happened? Yeah. Okay. The second possible way for you to execute SQL queries are prepared statements. Prepared statements happen when you execute them from SQL Server Management Studio or when you execute SQL prepare methods in ODBC and TotalDB. You can get statement like this and you can explicitly define your parameters. So when this query goes to SQL Server for generating a plan cache, it will use parameters straightforward. It will not try to auto-parameterize and everything. And then you can just execute it. And then you run sp unprepare, SQL unprepare. So you get rid of that plan, for instance. If you need to execute dynamic SQL, this is the only proper way to do that. And I cannot stress enough, honestly. sp execute SQL. Because, okay, not every application can get use of stored procedures. Or people just decide to get their logic, their application logic or business logic in the application layer. So they're not using stored procedures. So they have to use sp execute SQL. But when you use it, please make sure you define your parameters and the size of those parameters. Like here, take a look. I am defining my parameter definition to have only one parameter, which is product ID, and that type is integer. Now, if it was an nvarchar or decimal, I would have to specify the length. You can choose not to specify nvarchar 20, for instance. But if you can do that, and I'll show you why. SQL Server is doing parameterization, as I mentioned, and whenever you submit those queries, for instance, if you submit them as ad hocs and there's no auto-parameterization happening, then SQL Server will execute the first query, which has parameters 1, then 2. Then it will execute and cache the second query, which is practically the same, just the order of the parameters is different, right? And only if you execute the same of one of those queries, only then the plan will be reused. which is waste of space and waste of compilation energy and resources. So SQL Server is trying to do parameterization, and that parameterization is happening like that. The moment you execute it, if it's able to do a save plan, as I mentioned, then SQL Server will produce this plan, and every other query will reuse that execution plan. You can decide to force parameterization if you decide that you are cleverer than SQL Server. You can always do that. But it will always hold a risk for your queries to be, let's say, not running in the optimal way. What will force parameterization do is it will look in pretty much every single literal that you have in your SQL Server and will try to exchange it with a parameter. But again, only and only if it is able to produce a safe execution plan. So keep that in mind. Okay, let's continue with demos. Any questions so far? No questions? Okay, obviously I explained very well. So again, AdventureWorks, free prod cache. I'm going to run some workload, and I'll show you how you can actually read with query, with text query, the plan cache. I mean, you read the plan cache, so it's practically an XML. So you can do whatever you want with that XML. And in this case, and in the examples, I will give you those queries which you can use. And this particular one will give me all the cached plans with all the parameters and whatever. All the parameters and the values that SQL Server used when it was compiling the plans. So you know what was the first SQL Server, what was the parameter that SQL Server used to firstly compile that query, that execution plan. And this is important, especially when you look for outliers on performance. Like you see your query is running really slowly and you wonder why. What is the execution plan? Why this plan was generated like that? Can I investigate? Can I simulate it on my test environment? In order to do that, you need to know the parameters which were used for generation of that plan. Now, let me show the ad hoc statements. And as I mentioned, this is the only correct way of doing it. So I am declaring my SQL command, I am declaring my parameter definition and my parameter value. And I'm using SP execute SQL, providing the command, the parameter definition, the parameter that I've defined here to pass as a value. So I'm executing this one. Yeah, whatever. Okay, now take a look what happens in my execution plan. Just a single value. See? And that value is product ID as a parameter. Now I'm going to free my procedure cache and show you what are the other ways that I have seen people do that. Now, people can sometimes use exec directly. And this is a valid way of executing ad hoc. Now I see people laughing a bit. So are you using exec in your production environment? I don't want to admit, I know. Please stop doing that. Why? Okay, obviously it is a parameter, it is a statement, but take a look how SQL Server is caching that. Do you think it's okay? I don't. Why? Because instead of a parameter, I get a literal value, which means that if I execute the same query but with a different parameter, what do I get? Another execution plan. Yay. And what? Yeah?
Different parameter value.
Yeah. Different parameter value. Yeah. Sorry. And I'll show you. It doesn't look like that pretty, but see, this is my select star from production, and now I'll expand it. Now, see, SQL Server cannot auto-parameterize those at all. So, SP execute SQL. And take a look how SQL Server is storing that execution plan as an ad hoc. And what's worse, this cache plan might never be reused. So it's taking 131 kilobytes. Now can you imagine this 11 megabyte execution plan not being reused? I execute 100 queries and then my plan cache is down the drain. And I need to start some plan cache cleaning and everything else that I'll get to later on. Now, how we can work on sizing and decreasing the footprint of those ad hoc statements. There is a setting, instance level setting on SQL Server, which is optimized for ad hoc workloads, which by default is turned off. And in 99% of the cases I recommend it's turned on. But we'll get there, because I have a tool question on this demo. Now, I'm getting the same query like before. I'm executing it, no results whatsoever. Now, take a look at my plan cache. It's still the same query, right? But it's storing only 384 bytes. A lot less than 131 kilobytes, right? Like 100 times less or something like that. And take a look at what object it is storing. A plan stub. So basically a footprint of the plan handle. Let's call it like that. Okay, good. Is that a good solution? What will happen if I execute my query again next time? Will it have to produce a new execution plan every time? What do you think? Let's do it. It's the same execution plan, but this time, because it's my second execution of the same plan, SQL Server is storing the entire plan. See, now the size is 131 kilobytes. So, optimize for ad hoc workloads. If you run ad hoc statements, will generate plan stub the first time you execute the query, and the moment you repeat it, it will generate the full plan and it will store it. But it will help you for all those cases with single plan ad hoc statements.
So what's the bad part about it? It's not a default. It helps so much.
The bad part is that you still have to go through 2 full compilations. And imagine that 100% of your workload is ad hoc statements. And actually when you have to write plan stub and then you have to move that plan stub because it's in a different cache store and you have to go back and execute in the different SQL plan, then you move hash tables, buckets and so on and so on. It's a bit more computation. Plus, as I said, you get 1 more compilation and it really depends on the workload. But 99% of the cases, it's like, okay, please do it. Now,
Sorry.
Yeah?
So for the second time, it's not really used. Only the hash was stored.
Yes, it sees that it's okay. It's going through a recompilation event, but the storage part is at this time basically storing the execution plan as a whole. So it has to. It requires a bit more resources on storing the execution plan. So I wouldn't call that exactly reuse.
Really build it again?
It's still the same plan handle, it's still the same SQL handle, it's still the same everything, just the sizes are different. And the second time you compile, you just have a bit more overhead on storing. But that's the same resources that you use when this is turned off anyway.
And question, when I use store procedure.
And this is a tool question, come on. I will ask that question for you. What is going to happen with stored procedures?
I think it's compiled immediately. After 1 hour.
Yes. This is my third tool question. There you go. Yes. So basically, if you have major workload that is running on stored procedures, this setting is perfectly safe. And it will save you space. I have an ISV in Bulgaria that provides solution for, okay, I wouldn't say because it's going to be on camera and they might see it. Basically, they're using 99% of their statements on ad hoc basis. And it's not like they're doing it on purpose, it's because of entity framework and ORM models that generate sometimes not perfect code whatsoever. And I will show you that because we're getting close. Now, please don't mind the way I wrote this. It's a sample and some modifications, so it's not the best code ever. I mean, I don't pretend it to be. I just want to show you. It's a simple application that asks three times for me to provide parameter for a class, and it's doing a select statement. Get classes, yeah. I'm doing this. So basically, I'm doing select star from DB of course, where title equals the input parameter. So, enter class name. Now, I will not enter valid classes whatsoever. I'll just put one. So, I've added three different values. Now, my question for you is, what will we see in the execution plan? What do you think? So, the values that I've submitted are 1, 2, and 3.
You see the same query, but the size again is the same plan, but the size is growing. It's the same scenario like we had before. First.
Come on. Okay. Kind of strange, huh? I have two plans. Why do I have two plans? Yes. Basically, SQL Server is calculating the size of the parameter when you do not define it in your code. It's calculating it at runtime. So, if you have parameters like input, user input, and every time you get different length of strings and stuff like that, every time you get a different execution plan. And it's same with decimals. And it's same with simple parameterization. Imagine that you push a query against a decimal column in your SQL Server code, in your SQL Server table. And the first time you submit a value that is 1. So the SQL Server will do auto-parameterization against that decimal parameter and it will define it as decimal, guess what? Exactly, 1,0. So the next time you submit the same query, but with value 20, all of a sudden the 20 cannot fit in this decimal 10, right? So SQL Server will have to do a recompilation. So auto-parameterization is not always the best thing. So keep in mind, when you can, please define the parameters in your source code. Please. And don't tell me that you cannot do that, because you can. You only need as in my case. I'm still using the SQL parameter method property, and I'm still providing in all the details. But as you can see, you can choose to provide the size of the parameter, but you can choose not to. So if I change this one, I'm going to use the same values. DBC free pros cache, DBC free pros cache. Sorry. In the meantime, you can think of questions. Plan bloat, there it is. Now it's cleaner Outlook. See? I've defined this and it came here, parameterized with varchar 100. And it was reused, okay, I don't have the reuse column, but it was reused 3 times. Cool? Questions? Yeah?
But in this case, you need much more work if you are extending the field size in the database, for example. Then you have to go through the source code and change every size.
My question is, why wasn't it done in the first place?
No, you know.
See, this, yeah, well, it is something that you have to change and you have to count on. I know it's overload, but can you imagine this thing killing your performance and scalability? Because this thing you cannot fix anyhow, in any other way, no way. And the sad thing is that the earlier versions of our entity framework and all those other ORMs are doing pretty much this, which I hate. Yeah?
Not everything.
Okay, not everything. Sorry for the generalization. Which is not.
And Hibernate, for example, the reuse is a bit different.
Ah, okay.
It will actually even complain if you don't provide.
Ooh. So and Hibernate is clever. Good for it. Now, couple of final words, and I won't touch the recompilation part, but you'll get it as part of the slides. I want to give you some details on how to monitor the plan cache. And first, this is perfmon, and this is the only way where you can monitor parameterization. So you can have the plan cache hit ratio, the auto parameterization per second, forced parameterizations, fault auto parameterization per second, if you think that you have parameterization issue. Now, the cost of plan cache entries and the issues that we have with plan cache. When we store a plan cache, each plan cache in the cache stores has cost. For ad hocs, this is 0 and is increased by 1, the value 1, every time you reuse that ad hoc. If it's a store procedure, the cost is maximum of 31 and is based on 3 different parameters. The first one is I/O. So how much I/O am I going to need to compile that execution plan? And this value can go up to 19 ticks. Context switches, each tick up to 8. And then for memory, for every 16 pages, we get 1, up to 4. So the maximum is 31. And this is the cost that you can get for an execution plan. Under pressure, which means when you reach 50% of the target size of your plan cache, you will get a memory pressure event, which will start evicting plans. Not evicting, but decreasing the cost, and a different thread will start evicting it. The cost will be decreased with 1 every time there is a memory pressure. 1 round of the clock hand decreases with 1. The moment you reuse that execution plan, it's reset to the original value. Now, when we have memory pressure, just 50 seconds, First, external memory pressure is when something else outside the SQL Server exe process is pushing, like antivirus, or backup software, or the application server that is running on the database server, for instance. You have those, right? Internally, when any of the cache stores reaches 4 times the size of its hash table, so for SQL plans it's 160,000 records, or reaches 75% of the target time of the target memory, or 50% of the multi-page allocations, it will trigger a memory pressure, internal memory pressure. The moment we trigger internal memory pressure, we push a notification, and the next time a thread has to write an execution plan and sees that there is a memory pressure event, first it will have to push out an execution plan so it can store its new execution plan that it just evicted. So all of a sudden, a new compilation may take a lot more time than just the compilation itself, because it's a synchronous event. If I see a memory pressure and I need to push a plan that's above my target memory, then I have to wait to evict some execution plan so I can push my plan in. I don't have the time for demo. I'm sorry for that. Any questions at this point? Okay, you can ask me questions. I'll be for 30 more minutes around here, then I have to leave for Bulgaria. Really want to thank you for joining me on this session this morning. You survived, so did I. Again, thanks to the sponsors, thanks to the organizers. Don't forget to fill out the survey. And again, if you need any question, if you want me to help you with anything, I'm just outside. And I'm leaving you resources and my contacts as long as you want to find me in any social network whatsoever. I'm pretty much everywhere. I try to use everywhere and respond promptly. But please keep in mind that sometimes it's impossible. So, thank you again and enjoy the rest of the conference.